Hi everyone, and welcome back for another episode in our Shooter AI tutorial series. Last time we managed to get our actor to shoot at us as well as chase us, and we also in the last episode made them able to detect when they're being shot towards or near. Okay, so when that happens, we want to be able to make them run to cover and find cover and then run towards it. So in this episode, we're going to work on how to make them find cover. So to find cover, we're going to be using the EQS system, but we're going to be doing something a bit different today, and that is making our own generation. So to explain this in detail, let's start at the very beginning. Let's create a environmental query. So go to Artificial Intelligence and Environment Query. And this one's going to be called Find Cover. And the purpose of this cover is we want it to find a point that is still in line of sight of the player, but not, because we want to be able to make them hide behind it, crouch behind it, and then pop over the top and shoot at the player. So it's quite a complicated query, really, because you're trying to find a point that is simultaneously can be seen and can't be seen by the player. So the way this works is that we have to generate our own points. Now the reason why we have to do that is because if we were to use a normal generation and go from here and go generate one of these points here, like a circle or grid like we have done previously, we're just going to get a load of points and it's going to be hard to determine what ones we want. So an easier way of doing that is creating our custom own generation. So to do that, you go right click, new blueprint class, and in your all classes box down the bottom, you want to search for generate or begin start generator. Sorry, and you see environment query generator blueprint base. Choose select, and you want to name this one generate cover points. Open up this generation. So this is going to be a function that we do in here, which is going to generate those locations that are seen as cover. So how we're going to do that is first of all we have to tell it we're going to be generating locations and not actors. So what we're looking for is placing points arbitrarily around the world rather than at specific actor locations. So with class defaults ticked on, so select it. On the right hand side of the details panel, you will see the generate item type, and by default it says actor. You want to change that to point. And that means we can now use locations as our end sort of goal. Okay, now on the left hand side you'll see functions. You see there's one overrideable. That's the one we want. So go to override and say do item generation. And this is the function that does all the magic. So this is the thing that generates those locations. This input we have here, this parameter here, this context locations, are all the locations fed into it as the context being fed into this EQS environmental query. So we'll come back to that in a moment. So I'm going to go and break the return node off, because we'll do a few things first before this happens. So the way this is going to work is that we're actually going to do a line trace out from starting from away from the player, going in towards the player, and if we hit a wall, that's going to be determined as cover. Okay, and we do various tests on it to make sure it is actually cover, but for now we're just going to worry about getting it basically getting a location. So the way this is going to work is we're going to do a radial line trace. So we're going to do a line trace out from the player into the player character. Basically, we're doing a reverse line trace on the player character. So rather than the player character line tracing out, we're having a line trace starting from out to go in, and we're going to do that 360 degrees around the player. So to do that, we have to first of all do a for loop. And the for loop is going to be there to help generate those different spokes of the line trace. And how many you do is up to you entirely. It depends on how accurate you want your cover system to be. So I'm going to plug that into there for now. we'll come back to this. We're not done. We'll go through it bit by bit. So this for loop, I want to do it at every 36 degrees. No, every 10 degrees. Okay, so 360 degrees divided by 10 equals 36. So I want 36 indices. So the first index is 0. So my last index will be 35. Give me 36 indices. So with that index coming out of here, I'm going to multiply that by my float, which is going to be 10 degrees. And that should give me a full 360 values, because the for loop is going to go through each of these indices. 0 times 10 is 0, 1 times 10 is 10, 2 times 10 is 20, and so on and so forth. And it'll keep going until it gets to 350, and then back to 0, which is 360 as well. So that gets us the spoke. We then are going to get the make a rotator, and we don't want it into X, we want it into Z, because we're rotating around from the top of the player. So imagine there's the player's turning around on the spot. That's what the Z's can be doing. Okay, so that rotator is making a value making a rotator value there. So this rotator here, we're going to rotate vector, and basically going to turn a value around, and the value we want to do is just x equaling 1, and that basically x, if you think of x as forward, so x1 is direction of forward, so this is forwards, this direction. So think of this as a direction, and as we rotate it around in the z, so therefore the direction will change as this vector is rotated 36 times. Hopefully you're still following. Once we've got that, we'll have 36 values coming out of here. Those 36 values will then need to be set as the starting location. So this is just a value, isn't a location yet. Okay, it's an offset from a location. So we want to add it to the player location of the the player. So we have to get player location, or get player character, sorry. And then from there we can get actor location. The get actor location, we can then add that to our value here, and then it gets us a starting position. Oh, sorry, we have to multiply this first value by the length of the actual line trace, the radius of the trace. So float goes into there, like so. And this float is how long, how far away do you want the cover to be found. So I'm going to do it at 1000. And if you wanted to, you could make this a variable. So I can make this a variable called radius, and make that a float, and plug that in like so. Compile it, and the default value I'm going to set it to 1000. And compile again. So this can go into our start of our line trace. So let's do a line trace by channel, and that goes into the start. And then you want to hook up the execute pin to the loop body. So it's going to do 36 line traces every time it calls out environmental query. So now we need the endpoint, and the endpoint is simply just the actor location, but it's going into the actor. Okay, so now we've got all these spokes happening. We have an out hit here, which is going to determine whether or not we hit something on that line trace. So on return value, hold down B and left click to create a branch, plug in that return value, and if this return value becomes true if it hits something. Okay, so if it hit a wall or anything solid that blocks the line of sight, then that line trace will come back true. If it's true, this out hit, we want to break this to get all the data that we have retrieved from it. And from there, we want to add this to a array. an array. To do that, we're going to go into variables, and we're going to call this location set, and this will be a vector and an array of vectors. So click on a little pill thing and change it to an array over there. So if I just drag this out and choose get and then add, I can then add the impact point of the line trace to that location set. Now, with that done, we can go over to the completed part of this for loop. So when it goes complete here, we can then go and return it. But we can't just return it because we've actually got to tell it to add those points that we've set in our location set here to the EQS generation. So drag your location set out here, which is get, and we do a for each loop. And that's going to connect to the completed. Then the completed for this second for each loop will go into the return node, and then for the loop body of this, we're going to add generated vector, and this will add one of those EQS points onto our level. So this will add that vector point here, and then return it at the end. Click compile. Okay, so let's go back to our find cover. Our find cover EQS here. We can then come out from the root, and you'll see our custom one is now appearing as generate cover points. We can choose that, and here you can see where you can alter the radius if we like, and whatever we want. Make sure your generated item type is set to point. If it isn't, go back into your generate cover points, click on class defaults, and check it over here on the right. With that done, click save, and I think it'll work without nothing on it. We could be able to see it. Go back to your enemy behavior tree, and here we're going to just simply, just to test it out, I'm going to disconnect everything we have here, holding down Alt, and I'm just going to run an EQS, just so we can see if what we've got here is working. It doesn't matter, everything here, we just want to see the code working. Okay, so if I push the apostrophe key while looking at my AI, and turn on my EQS settings, something isn't working. Okay, so let's have a look and see where we've gone wrong. Run EQS, we actually set the EQS over here, so we've got to change that to find cover, click save, and click play. There we are. So you can see it lagging, and you can see the points generating. Now the lag is happening because if we go to our generate cover points here, we're all the time adding to this array. Now the deep problem is with that, we're not never clearing it. You may have seen some cover points there that were invalid but still showing. That's because this array still existed. What we need to do is at the start here, take this location set array here and clear it. So every time it generates a new set of cover points, it's got a whole new empty set of points to add to. So now if I push play, that lag should be gone, which it is, and I can turn on my EQS and I can see it generate those points on cover. Okay, and you see it's generating them outside, away from the player on these edges, like so. So why is it not generating behind these pillars? Well, if I turned on the line trace, you should see that line trace is actually skipping above it. So if I change my draw debug type here to 1 frame and click compile, it's quite faint to see. I don't know if you will be able to see it, but the line trace is just skimming over the cover. So how to fix those issues? Well, what I want to do is we also get actor location here from the get player character. I actually want to project that down to the navigation mesh. So type in project point to navigation, and that project point is now your new vector that you plug into the addition here and the end. And on filter class, just change that to recast filter, use default area, and that tells it to use the nav mesh that we've currently got. So now if I push play and turn on those points, you'll see it's now generating the cover points on the other side of these walls, which is all fair and good. However, we can make this a bit better still, because this cover, you can see that it's spawning the points exactly on where it hits the wall. Now, if I were to tell that enemy to walk towards that point, it will never actually reach it because it is too close to the wall. It's difficult to get to. Okay, so what I'm going to do is just offset the location result by about 50 points, 50 units, and push it away from the wall a bit, so the enemy can then safely sit behind the wall and meet its target. So if I hit escape there and go back to our generate cover points and go towards the end where we've got our break hit result. So we've got impact point and we've got our normals. Our normals are what we're going to use to determine how far we got to go. The normal is basically the direction of the wall that is facing. Okay, so if I take the impact normal and say multiplied that by a float, this is how far away the offset, basically how far away I want to offset the point from the wall. So if I type in 50 here and then add that to the impact point, like so, this will now offset those points away from the wall. You can see them away from the wall and a lot easier for the player to find. If I move around here, you can see those points will disappear and go to the other side of the wall. Okay. So now we need to make the enemy run towards the closest one. And we're just going to do the closest one for now. There will be other stuff we need to do to it because we want to make sure that the enemy can still see the player and so forth. So let's actually do that first, because we want to get the point, as I said at the start, to not only be hideable from the player but also be visible to the player. So if I actually, after we do this addition here, because the line trace has already happened, I could offset these points in the Z value by about 50. I click compile, and let's see if that's tall enough. You'll see it lifts the points off the ground. See, I want to make it higher a bit more because I want them to appear above the cover. When you're making your game, you want to set your cover to be two values. Okay, one will be a full height value and one will be a half height value. All your cover should stick to that sort of template. Okay, if you're making a game with multiple types of cover, multiple heights of cover rather, then you're looking at a lot more complicated system, which we're not going to cover. But most games, if you look at them closely, you will see that most games have a cover at half height and a cover at full height. So let's increase the height of those ones a bit more to make them a bit happier. So I'm going to change that to 100. Click compile and play, and we'll see here, yes. So now the cover points, I've hit the wall and risen them up a little bit, and that means then I can make the enemy do a test on this to trace whether or not that point can actually see the player. So that'll do for this episode. We'll do the next episode is make the enemy run towards and first of all choose a point that is it's best suited, run towards it, and tell itself that it's in cover. If you have any questions about EQS system and I want to know a bit more how to use it, check out my EQS system series, a few episodes on that anyway, to get a better understanding of how it works. And if you've liked this video, don't forget to subscribe and like it, and leave a comment below if you have any questions that you want to ask. If you want to support me, head over to patreon.com/Ryan Laley, just like these wonderful people have done, and support me there. If you do just donate just $1, you get access to all the videos nice and early. You then get access to our Discord as well. And if you go for the higher tiers, you're going to get access to one-to-one tuition, project files, voting, and a lot more. Thanks very much to everyone who has supported me thus far. I wouldn't be doing this without you. It means the world to me. So thank you again. Can't believe the support I'm getting. It is truly fantastic. Anyway, that'll do for me. And thank you very much. And I'll see you all next time. Bye-bye.